Hey everyone, welcome back to the channel. I'm Ehsan, and in this new series we are going to take an ordinary Ubuntu server and turn it into a secure, CIS aligned, automation ready system using nothing but open source tools. This is Linux Server Security Hardening, a step-by-step series designed for network engineers, DevOps professionals, and automation enthusiasts who want to build servers that are not just functional, but resilient. In the world of network automation, Linux is everywhere, from your Ansible controllers, Nornir runners, and GitLab CI agents, to the container hosts running your API gateways. But a default Linux installation, it's not safe enough, as you know. It's wide open, optimized for usability, not security. So our mission here is simple: to harden that Linux host into a production-grade, automation-ready fortress following CIS benchmarks and industry best practices. In this series, you'll learn how to perform a security audit using Lynis, harden SSH and disable risky defaults, manage and disable unnecessary services, configure enhanced logging and auditing, lock down file permissions and cron jobs, implement fail to ban to stop brute force attacks, apply a UFW firewall with deny by default policies, and finally, validate everything through a re-audit. By the end, you'll have a hardened server scoring about 85 on the Lynis index, ready to host your automation frameworks with confidence. We'll rely entirely on free community-driven tools. We will use Lynis for security auditing and CIS compliance. We will use fail to ban for dynamic intrusion prevention, and also UFW for simplified firewall management, and rsyslog for centralized logging and monitoring. These are lightweight, enterprise-proven, and perfect for automation pipelines. If you're running network automation, your Linux host is effectively your control plane, the machine that connects to routers, switches, firewalls, and APIs. That means protecting it is protecting your entire network. Restricting access to just only automation and admin users should connect. Key-based authentication, as you know, no passwords, use encrypted vaults. Service hygiene, and as you know, disable every daemon you don't need. Logging and visibility for collecting logs from playbooks and pipelines. And finally, immutable infrastructure mindset, that is, treating the hardened server as code, versioned, rebuildable, and automated. These principles make your automation environment not just efficient, but secure by design. To follow along, you'll need Ubuntu. For example, you can use 24.04 LTS server or VM, a non-root sudo user, SSH access, a text editor like Nano or Vim, and basic command line skills. Everything we do here will run identically on a VM, a cloud instance, or inside your CI runner. Now let's see the roadmap. Before we dive in here, the roadmap for the entire journey. As you see, we will have 9 steps. And before we start typing commands, I want to show you the big picture, because Linux hardening is a single trick. It's a structured, layered process. Every stage builds on the one before it, just like network automation frameworks build on clear topology and consistent device states. This series is designed like a real-world project, we will move through 9 sessions, each representing a phase in your security journey. Think of it as a DevOps-style pipeline. We will start by scanning and baselining, then apply incremental configuration changes, validate results, and finally produce a measurable, auditable outcome. In the session 1, we have introduction and overview. This first episode, the one you're watching right now, sets the foundation. We will define what CIS benchmarks are, explore the open source tools we'll use, and establish the mindset of secure network automation. Because before we automate, we must understand what secure by default really means. In session 2, we will have initial security audit with Lynis. And we will run Lynis, an open source auditing tool that performs hundreds of checks like authentication, kernel parameters, file permissions, network stack, logging, and more. It gives us a baseline score and a detailed list of vulnerabilities, so we know exactly where to focus our efforts. In session 3, we will have SSH hardening. We secure the gateway SSH. We'll disable root login, enforce key-based authentication, change the default port, and add restrictions like max authorize and client live interval. This is where 70% of real-world breaches are stopped before they start. In session 4, we will have manage unnecessary services. We look at what's actually running on our system. Every unnecessary daemon is an extra attack vector. So we'll use systemctl to identify, disable, and remove what we don't need. This session teaches the principle of list functionality, a key CIS control. In session 5, we will have enhanced logging and auditing. We will strengthen visibility using rsyslog. We'll separate SSH logs, pseudologs, and privilege escalations into their own files. Set up daily log rotation and enforce secure file permissions. After this session, your system won't just be protected, it'll be observable. And in session 6, we will have hardened file permissions. We move deeper into the file system. We will lock down etc ssh, etc sudoers.d, boot grub, and cron directories. Set a strict default umask and make sure only root can touch sensitive configs. This stage builds the foundation for integrity and compliance. Because automation pipelines often run as a specific service accounts, and we want to guarantee those accounts can accidentally weaken the system. In session 7, we will have implement fail to ban. We will deploy fail to ban, which monitors authentication logs and dynamically bans IPs that repeatedly fail SSH or pseudo authentication. It's an automated shield, lightweight, reactive, and perfect for hybrid environments. And in session 8, we will have configuring UFW firewall. In this session, we will finalize our network perimeter using UFW, the uncomplicated firewall. We will apply a deny by default policy, allow only essential ports, and add SSH rate limiting to stop automated bots in the red tracks. And this session gives your system its outermost defense layer. And finally, in session 9, we will have final validation and re-auditing. We will circle back to Lynis. We will run a complete re-audit, compare the new hardening index with our baseline, and document our security improvements just like a professional compliance report. This is where you will see the results of every step, quantified and verifiable. So that's our roadmap, 9 tightly focused sessions, each building on the last to create a secure, automation-friendly Linux environment. If you're following along, you can treat this roadmap like a learning path. After every episode, run a quick rescan, commit your config changes to Git, and you will literally see your security maturity increase over the time. And by the end of this roadmap, you will have a server that passes CIS benchmark tests, automated defense mechanisms, auditable logs, and a hardened base OS ready to run Ansible, Nornir, or any NetDevOps workflow safely. So just review these 9 steps that we will have together. In the next, we want to talk about the next episode that we will kick things off with a security audit using Lynis. We will scan a clean Ubuntu system, interpret the results, and build our to-do list straight from real data. So get your server ready, because next time we start securing for real. But before closing the session, let me show you the CIS benchmarks that you can find. Here you can complete the form and get access to all of benchmarks, and you can download the PDFs for free, and you will have these links in your email. For example, here we have Ubuntu Linux. We will see the CIS benchmarks for different versions. For example, for Ubuntu Linux 24.04 LTS version 1. And also, as you see in the steps, we will work with Lynis, that is useful for auditing, system hardening, and compliance testing. And as you see here, Lynis is a battle-tested security tool for systems that is running Linux. And it also performs an extensive health scan of our systems. And also, we will go through fail to ban. As you see, it will ban hosts that cause multiple authentication errors. And it will scan log files like varlog, auth.log, and bans IP addresses conducting too many failed login attempts. So, for the closing scene, if this roadmap excites you, hit that like button, subscribe, and turn on notifications so you don't miss a single step. I'm Ehsan, and this is Harden Your Linux Server for Security Hardening as a Network Automation Engineer series. Let's make your automation stack secure, auditable, and future-proof. Thanks for watching me.